Hi guys, so we have this problem under momentum and collision. Let's see how we can break it down. It reads above mass 2.4, so that is m1. This one here is moving horizontally with a speed of 3 meters per second. So it collides, but the collision is not head on, it's at a certain angle. The second ball, which is this one, which is going in the opposite direction with a velocity 5. So the first ball bounces off the second ball with an angle of 60 degrees and the speed of 1.5 meters per second. So we're being asked to find the final velocity of the second ball. That's the first question. So we're going to break down this question so that at least we understand what we've been given. So to start with, let's see what we have in the question. We have been given mass for object 1. So let me just put it here. So mass 1 is 2.4 kg. We've been given mass 2. Mass 2 is 1.5 kg. Okay. We've been given the initial velocity for the first object, which is this one. So we're going to say V1. Initial velocity is 3 meters per second. What else do we have? Velocity for the other one, initial as well. We have 5 meters per second. Then we've been given the final velocity for object 1. So V1 prime. Final velocity is 1.5 meters per second. What we're looking for is the final velocity for the second object. Okay, so now that we have this, what we can do is, so now let's go back to this part here on the diagram. So after collision, this object went in this direction with a speed of v1 prime. So let's just draw a line here like this. This will help us understand it better. And the other one went in that direction as well. Okay, so because of that, what we're forming here is a right angle triangle with their particular directions. So this is a component in the x-axis and we have a component in the y-axis. So this here is v2 prime. Same thing here, we'll have a component in the x and a component in the y. So this resultant, remember we're forming a right angle triangle. This resultant here is v1 prime. Now, because this is in the y and it's opposite to our angle theta, this will be v2 prime sine theta. Remember opposite, we use sine. Then this one here is adjacent, so this component here will be v2 prime cos theta. Same thing here, though this time around we have an angle 60, so this will be v1 prime cos. This is adjacent, remember. Then this one here will be v1 prime sine. Let me use the actual angle, which is 60. So sine 60. That. So now that we've broken them into components, we are going to sum the momentums in the x-axis and in the y-axis. Since momentum is conserved in all momentums, since momentum is conserved in all collisions, we can easily say, now this is the x-axis, the summation of momentum initially in the x is equals to the summation of momentum final in the x-axis, like that. So since there are two objects of interest, we're going to say P1, momentum 1 plus momentum 2 is equals to momentum 1 prime plus momentum 2 prime. So the prime is just representing the final momentum. Now we know that momentum is mass in motion, so we can say mass times velocity plus mass times velocity is equals to mass times velocity 1 prime plus mass 2 velocity 2 prime. Prime to represent, of course, the final velocity. Now, our focus in this case is in the x-axis. So, mass 1, we say that is 2.4. So, let me just demarcate here. So, mass 1 is 2.4. V1, Where is V1? The initial velocity is this one here. Now, initial velocity, you've been given 3, but because it's going to the left, we're going to consider it as a negative. So, negative 3 plus M1, sorry, it's supposed to be M2, M2, V2. The first object, M1, is M2, yeah. Okay. So, mass 2 is this one here. The mass 2 is 1.5. So, 1.5. Velocity 2, the initial velocity for 2 is 5. So this one is a positive because it's going to the right. This is equals to M1 again is 2.4. But V1 prime, which is the final velocity for 1. This is object 1. So V1 prime in the x direction, what we have in the x direction is this here. Now, because it's going to the left, we're going to consider this as a negative. Hence, we'll say, open bracket, negative V1 prime cos 60. Like that. Then we say plus. So mass 2, we have 1.5. And V2 prime, remember, V2 prime in the x-axis is V2 cos theta. So V2 prime cos theta. Okay. Now we can start doing the calculations. So we have 2.4 times 3. By 3, we're getting 7.2. So negative 7.2 plus 1.5 times 5, that should give us 7.5 is equals to, remember, V1 prime we have is 1.5. So we're saying 2.4 times 1.5 times cos 60. So let's see what we get. 2.4 times 1.5, the final velocity, times cos 60. We're getting 1.8. Now, since there's a negative, this will be negative 1.8. So we're saying plus. We don't have V2 prime and we don't have theta. So this will just remain as 1.5 V2 prime cos theta. We don't have these two. Remember, we don't have this and we don't have the angle theta. Okay, so 7.5 minus 7.2, we're getting 0.3. So this is 0.3. This 1.8, the negative can cross the cosine, so it becomes positive 1.8 is equals to 1.5 V2 prime cos theta. So if we try to rearrange this, we can have 1.5 V2 prime cos theta is equals to 2.1. We're going to divide both sides by this 1.5. Hence, V2 prime cos theta is equals to, so let's see what we get. 2.1 divided by 1.5. We get 1.4. Now, this has been obtained in the x-axis. So let's just call it equation 1. So now what we're going to do is we're going to go in the y-axis to see the equation that can be formed in the y-axis. So using the same approach, same way we did in the x, we're going to do the same thing in the y. So now in the y, so this is y-axis. So again, momentum is conserved. So summation of momentum initial in the y is equals to the summation of momentum final in the y, like that. Then P1 plus P2 will be equals to P1 prime plus P2 prime, like that. Now, I just want us to get everything from the diagram. So we know that this is M1V1. Momentum is just mass times velocity, plus M2V2 is equals to M1V1 prime plus M2V2 prime. Okay. So now that we have this, from our diagram, mass 1 is 2.4. So mass 1 is 2.4. Velocity 1 is 0. Because remember, these objects are moving in the x-axis, meaning that in the y-axis, there is no velocity, hence 0. Mass 2, the same thing, is 1.5. but velocity initially is 0. We go to the other side after collision. Mass 1, 2.4, v1 prime. So the final velocity of v1 is this one in the y-axis, which is v1 sine 60. Now, since it's pointing in the downward direction, it will be a negative. So negative v1 prime sine 60 plus 1.5 mass 2 v2 prime. Now v2 we don't know, so v2 prime is this one here in the y direction, which is just v2 prime sine theta. So leave it as it is, which is v2 prime sine theta, like that. Okay, so now that we have this, let's put it here like that. Now that we have this information, we can say everything this side we just give us a 0, which is equals to, so let's multiply v1 prime. We have v1 prime. The value of v1 prime is 1.5. So we can do the substitution. So what we're going to multiply here will be 2.4 multiplied by v1 prime, which is 1.5, multiplied by sine 60. And we're getting 3.12. So this is equals to negative 3.12. If we multiply everything here, v1 prime is 1.5. So plus, remember we're adding it to this, which is 1.5, v2 prime sine 60. Okay. So if this guy goes to the other side of the equation, what we're going to have will be 3.12 is equals to 1.5 v2 prime sine 60. We're going to divide both sides by 1.5. 1.5, we're getting 2.08. So v2 prime sine theta is equals to 2.08. Now this is equation 2. So we're going to combine equation 1 and equation 2 to find the value of final velocity. So here's how we're going to do it. Remember, let's pick up equation 1. Equation 1 was v2 prime cos theta is equals to, what did we have? 1.4. Like that. This is equation 1. So to find the value of v2 prime, we shall make one of them the subject to the formula. Let me start with from equation 1. If I make v2 prime the subject, I'll have v2 prime is equals to 1.4 over cos theta. Remember, this is from equation 1. I'll throw it into equation 2. So I'll just bring it here. So in equation 2 here where I have v2 prime, I'll put 1.4. Let's do this. 1.4 over cos theta. So I've made v2 prime from equation 1 the subject, and now I'm pushing it into equation 2. So here where there's v2 prime, I've put that sine theta is equals to 2.08. So this will give me 1.4 sine theta over cos theta is equals to 2.08. Now, trigonometry mathematics, it's important to note that sine theta over cos theta is equals to the tan theta. So this is the concept we're using here. That's just an identity. So this means that what we have here, sine over cos is just tan. So 1.4 tan theta is equals to 2.08. We divide both sides by 1.4. Hence tan theta is equals to 1.4, let's just say 49. So the tan inverse of 1.49 is 56. Hence theta is equals to 56.1 degrees. We're not looking for theta, we're looking for the final velocity. So v2 prime, I'm now using the subject, is equals to 1.4 divided by cos theta. So that is cos 56.1. So let's see what we get. So 1.4 divided by cos 56.1. Hence, v2 prime is equals to 2.5 meters per second. So there we have it. We have found the final velocity. Now, the next part of the question, let me just take you back to the question. Next part of the question says, calculate, or rather, how much kinetic energy is lost in the collision. So to find the kinetic energy that is lost in the collision, we're just going to subtract the two kinetic energies that we're going to have in this case. So the loss of energy is equals to the final kinetic energy minus the initial kinetic energy. So this is part B of the question. I'm just write it here. So energy lost is equals to final kinetic energy minus the initial kinetic energy. Okay, so the final kinetic energy, what do we have? Now for the final kinetic energy, which is after collision, remember we have two velocities. So I'm going to say the final kinetic energy for object 1 plus the final kinetic energy for object 2 minus the initial kinetic energy for 1 plus the initial kinetic energy for 2, like that. So now, what are these particular energies? So we can say kinetic energy for 1, final. Remember, kinetic energy is half mv squared. So object 1 is this one here. So half m, what's the mass for this one? Mass 1 is 2.4 v squared. Final velocity for this one is 1.5. So 1.5 squared plus kinetic energy for 2. This is after collision. So again, it's half m. What is the mass for mass 2? 1.5 v squared. The final velocity that we just calculated is 2.5, like that. Now this represents the final kinetic energy for both objects. Then we add them up. Now we subtract this from the initial. So for object 1, again, it will be half. Mass is 2.4. Velocity, what was the velocity for this one? Velocity initial was 3. Remember the squared here. So 3 squared. We're adding it to the initial kinetic energy for object 2. Just put it here. So half. Mass for object 2 is 1.5. And the velocity for object 2 was 5. So that is 5 squared. I hope you're able to see. Okay, so let's just do all the computations here. So I'll add this part and this part together. Let's see what we have. So half times 2.4 times 1.5 squared. So for this part, I'm getting 2.7 plus, for this part, half times 1.5 times 2.5 squared. Here I'm getting 4.7 minus, let me add here, so half times 2.4 times 9. So here I'm getting 32.4 plus this part here, so half times 1.5 times 25. I'm getting 18.75, something like that. Okay, so just find the final answer. So what we're saying here is 32.4 plus 18.75 minus 2.7 plus 4.7. So everything is resulting to a negative 3.8 joules. So this is the amount of kinetic energy that was lost in this particular collision. So that's how it's done. Thank you very much. In case you have a question, please feel free to drop in the comments. Have a good day.